Hi guys, here are the answers to your starter questions for today's lesson. So question 10, we have a straight line has the equation 3x minus y equals 9. And we're also told that a second line is parallel to this and passes through the point 5 minus 3. Write down the equation of the second line. So anytime we do any straight line questions, we need to know two things. We need to know the gradient of the line and then also one point that the line passes through. So we have a point the line passes through, which is 5 minus 3. We need to work out our gradient. Now, because we've been told that our line is parallel to this first line, 3x minus y equals 9, we can rearrange the first equation into y equals mx plus c, and then we can identify the gradient. So the first thing we need to do is rearrange this first equation. So we've got 3x minus y equals 9. So the easiest thing to do here is we are trying to rearrange this into y equals mx plus c. So because we have a minus y, if we add y to both sides, we're going to turn that positive. So we're going to have 3x equals y plus 9 or 9 plus y, whichever way around you want to write it is fine. I'm going to write the y first. And then what we would do here is switch this round. So y plus 9 equals 3x. And then we just need to take away 9 to the other side so that it's in the right form. So we've got y equals 3x minus 9. So from this is now in the form y equals mx plus c. So we know our gradient of our line is 3. So that's the number in front of the x term is your gradient. So we can pick that out really easily. So now all we need to do is do our equation of a straight line. So we're going to use y minus b equals m bracket x minus a. So we have our gradient is 3 and we have our point on the line 5 minus 3. So that's a and b. So we're going to get y minus 3 equals 3 bracket x minus 5. So now we just need to break the bracket and tidy this up. So we've got y plus 3 equals 3x minus 15. And then the last thing we would do is take away 3 from both sides. So we've got y equals 3x. And we would take away 3, so minus 18. Okay, and that is the equation of your line just there. Okay, the second question here is a quadratic question. So we have here the equation of a parabola shown in the diagram, and we have the equation is y equals x minus 2 all squared minus 9. So the first question says state the coordinates of the minimum turning point. So anytime you see a question that says state, or it might say write down, it should be something really easy that you can just write down the answer to. So your turning point comes from the equation of your line. So our equation is y equals x minus 2 all squared minus 9. So we change the sign of this number in the bracket. So that's minus 2 in the bracket. So it's going to be a 2. And then we don't change the sign of the number at the end. So minus 9. So 2 minus 9 is your turning point. For point C, that point is lying on the y-axis. So at that point, we know our x coordinate is 0. That coordinate will be 0 something. So all we have to do here now is put 0 into our equation where the x goes. So we're going to have y equals 0 minus 2 all squared minus 9. So 0 minus 2 is just minus 2 squared minus 9. So minus 2 squared is 4 minus 9, which gives you minus 5. So the coordinate of C will be 0 minus 5. The last question here, question C, says that A is the point minus 1, 0. State the coordinate of B. So again, it's got that word state in there. It should be something very simple to do. So we know the point A is as an x coordinate minus 1. We know our turning point is 2 minus 9. So if we take that up to the x-axis, we know that the x coordinate of this is 2. So what we can do is we can use the fact that we know our parabola is symmetrical to work out this coordinate for B. So between minus 1 for A and that line of symmetry, if that x coordinate of A is minus 1, the x coordinate of our turning point is 2, that's 3 units between those two. So if we use that mirror image across the other side, that'll be another 3 units along. So our line of symmetry was going through x equals 2. So 3 more units onto that would take us along to 5. So for B, our coordinate will be 5, 0.